Okay, so question 12 here is talking about special triangles. Now, special triangles is a term for a couple of triangles we see a lot in trig, is the 45, 45, 90, and the 30, 60, 90. So they are right angle triangles, which means we can do trig for them. And we know that triangles that have the same angles, if they're angle, 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 they're similar triangles, right? And similar triangles mean that the ratios of any two sides will be the same. And that's what trig is based on, right? So I've probably asked you before to put in tan 45 into your calculator, and it should get 1. If you're not in 1, if you don't get tan 45 equals 1, then you're in rads, probably, and not degrees. This, if we can look at a triangle, just tells us that tan 45, so if that's the side we're working with, the angle, then opposite over adjacent equals 1. And you can kind of tell that with your just general number sense, that if we're going up at a 45 degrees, whatever we do in our run, we're doing in our rise. So the gradient is 1. Rise over run is 1, tan of 45 gives us 1. That means no matter what this length is, on any triangle that has a 45, 45, 90, this is the same length. We can tell that with, I guess, with this proof. So what this is generally shown as a special triangle is the, we make this 1. We make this 1 and this 1, we use our Pythag to prove that this must be root 2. This squared plus this squared equals this squared. So 1 squared is 1, 1 squared is 1 equals 2, 2 is root 2 squared. So that's our special triangle. And the 30, 60, 90 triangle is the one you would have discovered doing question 12. We have our 2, we have our 1, and then by the same Pythagoras working out, we can find this is root 3. So basically these special triangles, if you remember them, then you can kind of already tell, even without doing your trig, if you remember that these sides, then you know that any similar triangle that has a 30, 60, 90 will have these same ratios. So if you see another triangle, and that's 6, how do you find x? And that's 60, and that's 30, right? So root 3 over 1 is going to be the same as x over 6. Oh, sorry, there you go. So if you have similar triangles, you can work out the missing numbers the same way as we were doing with the similar triangles. You can work out your scale factor and do it that way. You can just do like a little equation to work out. So the question for part E was this. We have 45 degrees here, we have 90, 90, and we have 30 degrees here, and we have C, A, B, and an X. So it wanted you to find out the distance. Actually it said, prove that this distance AB equals root 3 plus 1 on 2x. So I want you to think about this in terms of what you know about similar triangles. This is a 45, 45, 90. This is a 30, 60, 90. They're going to have the same ratios as these special triangles, because all AAA, all similar triangles have the same ratios of their sides. So use that knowledge to prove that this distance is root 3 plus 1. And you can already see there's a root 3 here and a 1 here over 2x times x. And we think of that as root 3 plus 1 multiplied by x on 2. So think about that. There's an x there, x on 2. Can you see how you might get to this answer? How do you prove? All right, I'll let you work on that one.